I watched some Khan Academy videos, and I think I've got that figured out.
Okay.
But I was wondering if I could go over the last test because that was murder.
Yeah, for sure.
Are you the one that grades those?
No.
Oh, okay.
Sister Blackham.
Gotcha.
Is it multiple choice or the written part you want to go over?
The written part for now. I didn't do very well in the multiple choice either, though. So maybe that
Okay.
one.
Let's see. So it was week 11.
Yeah.
Okay, let me try to find it. Exam, multiple choice.
Yeah. Or no, the written question. Sorry, written portion.
Oh, the written. Okay. Okay, so it was exam 4A.
I think so. Yeah.
I think so. Let's see. So group number 1. Let's see.
Pretty sure.
Did you submit it online, or did you submit it?
Oh no, I had to email it to her because it wasn't scanning.
Okay.
I can send you the.
I think I can just get into just questions and then we'll just go over them. Let's see.
Okay.
Reading questions. Okay, so identify the 3 Pythagorean identities. This is the one, right?
Yeah.
Okay, let's see.
So I got that one right, I think.
Okay, this one is right.
Yeah. I'll pull up my grade so that I can see which ones. Okay. So number 1 was 3 out of 3. I got 2 right, and then number 3, there were some mistakes.
Okay, let's do that. Let's see, paint.
Let me see if I can pull up my answers.
Yeah. Okay, so what would you do the first?
All right, so let me find, as I emailed them to Sister Blackham, so be able to pull up my work.
Yeah.
Okay, I think this is it. Is it this one? Yeah, okay.
Okay, so what do you do first?
All right. So I wrote it out. Sorry.
That's okay.
And I can screen share, right?
Yep. Okay, awesome.
You got it?
Yes. Here we go. Okay, so this one is the third one. So you got rid of the sine. Secant is 1 over cosine. Wait. So meaning that secant, you can just disregard the sine.
You can.
Because of even and odd identities.
Oh, even and odd identity. Okay.
So do you have formulas for even and odd identities?
Yeah, I've got them in my notebook.
Okay, so try to look up and see what secant minus x equals to.
Secant of x.
Of negative x.
Yeah, secant of negative
secant
x
of x. Mm-hmm.
is secant of x.
Yeah, and the way you can remember it, all of them are, you can pull out this minus. There is only cosine, whose sign you disregard, as well as secant, because secant is 1 over cosine. So those are just two functions that you just disregard the minus sign.
Okay.
Okay,
Trying to pull up the original question just so I can see that. They didn't write the questions on my on my test paper, so I can kind of work through them again.
Mm-hmm.
It was a week. I don't know if I'm allowed to look at it again. Maybe I am.
If you are not retaking it, I guess you can. I don't know.
Okay, week 11 for. Oh shoot! No, it won't let me look at them. But you had them open, right?
Yep, I can screen share.
Okay. Okay, where was I at? This one. Okay. So 1 minus. So then you can just make it 1 minus secant of x, 1 minus secant of x?
Yes.
Okay.
And then you'll get 1 minus secant of x squared, right?
Mm-hmm.
And I don't know if you need to distribute it. Let's see. Let's distribute it. So we'll have secant of x squared. So it will be 1 minus 2 secant of x plus secant of x squared.
Mm-hmm.
So let's see. Secant squared x is what?
Secant squared x is tangent squared of x plus 1.
Yeah. I don't think it will help us. I think I would just leave it like that.
Okay.
Honestly. You won't be able to simplify it any further, right?
Okay.
Looks like it.
Okay, I see what I did wrong.
Yeah, you just that even or odd identities. It's kind of easy to remember them. Okay, let's go further.
Okay, let me find my grades again. So then number 4, that was just, I guess, some positive and negatives.
Okay. So, so number 4 was also not correct?
Mm-hmm.
Okay, let's do that. So we have cosine of 2 alpha equals to 1 over 3. 1 over 3.
Okay.
Right? And also it says that alpha is in the 4th quadrant. So alpha, 4th quadrant.
So.
Okay, just a second. I'll bring the formulas. Just a second. Okay, I'm back.
All right.
So, which formula did you use to solve this one?
So it looks like I did 1 minus 2 sine squared of alpha, or sine of alpha squared, equals 1/3, because cosine of 2a is, or cosine of 2 alpha is 1 minus 2 times the sine of alpha squared.
Mm-hmm.
Well, it's one of the, I think it's one of the double angle identities.
Okay, yes.
Is that the right one to use?
Well, you see, you don't know what alpha equals to. You just know that cosine of 2 alpha equals to. You don't know what sine alpha equals to.
Right.
Right. So it wouldn't really help you. Now, if you use, for instance, half angular identities. So let's see. So you have cosine x over 2 equals to plus or minus 1 square root of 1 plus cosine of x over 2. Okay, here's the trick. Let's substitute instead of x 2 alpha. X equals to 2 alpha.
Okay.
Substitute it to this formula. So we have what? Cosine of what?
Alpha?
Alpha, exactly, equals to plus or minus 1 plus cosine of what?
2 alpha.
2 alpha divided by 2.
Okay.
So you see, now we can find cosine alpha using this half angular identity because we know cosine of 2 alpha. Okay, so we have what? 1 plus or minus 1 plus what?
X? No.
Cosine of 2 alpha.
Oh, 1 plus cosine of 2 alpha.
And it means that 1 plus what?
1 plus... Oh, 1/3.
1/3, exactly.
Oh.
Yes. And then divided by 2.
Okay.
Okay, now we have to decide the sign, which sign to use, plus or minus. We are trying to find alpha, cosine of alpha. And they said that alpha in the 4th quadrant. So for cosine,
it's going to be positive.
It's going to be positive, right? In 4th quadrant. So we will use just positive. Okay. And then now let's simplify it. So here's 3. So it will be 3 plus 1 over 3 divided by 2, right?
3 plus 1 over 3. Yeah, okay. Divided by 2, so 4 over 3. 6 over 3? No. 8 over 3?
4 over 6, right? Because you have 4 over 3 divided by 2 over 1, and now times the reciprocal. So it will be square root of 4 over 6. And we can simplify it a little bit. It will be 2 over square root of
6. So it's 2 square root of 6. So it's square root of 6 over 3?
Yes, square root of 6 over 3.
Okay.
So we found cosine alpha. Let's write it down somewhere separately. So we have cosine alpha equals to square root of 6 over 3. Or we could also say it's the same as 2 over square root of 6, just in case. Maybe we'll need.
Maybe we'll need that. Okay.
Okay, and now, so knowing cosine alpha, we can find sine alpha, right?
Okay, yeah.
So let's see, alpha is in the 1st quadrant, to not forget. Okay, so what will we do to find sine alpha?
We could use the Pythagorean identity.
Yes, exactly. So sine alpha will equal to what?
Sine of alpha for the Pythagorean identity, that'd be 6 over 9. E plus sine of alpha squared equals 1. 8 over 9. Sine. So 3 square root of hold on.
So did you get this formula? To use this formula? Sine alpha equals plus or minus 1 minus cosine of alpha squared?
I think so. Yeah.
Okay, let's do that. So this is the Pythagorean theorem. Let's see, sine squared alpha plus cosine squared alpha equals to 1. Now we have to solve for sine alpha. So
Right.
subtract from both sides cosine squared alpha, right?
Right. So that's minus. That's going to be sine squared of alpha equals 3 over 9.
3 over 9. So let's check. So it should be negative 1 minus cosine squared alpha is 6 over 9, right? Then you'll have 9 minus 6 is 3
over 9.
Over 9.
So 1/3.
And then we'll have, yes, 1 over
Root 3.
So it will be square root of 3 over 3.
Okay.
And it should be negative. Did you get that? Because
it's in the fourth quadrant.
exactly, and we were trying to find sine. Sine in the fourth quadrant is negative.
Okay.
The sine positive here, and sine is like that.
Right. Okay. And then, so could I use the formula I used at the beginning? Could I use that now, since I know what the sine of alpha is, to figure out what the cosine of 2 alpha is?
We didn't need to figure out cosine to alpha because they gave us cosine to alpha.
Oh, right. So what was the question?
The question was to find 6 trigonometric functions. So it means to find sine alpha, cosine alpha, tangent alpha, secant, cosecant, this stuff.
Okay, so.
Okay.
So I got sine and cosine right, I think. Looks like. Am I still screen sharing with you?
Let me check. Oops. Yes, you are. Let me check. So sine alpha is negative square root of 3 over 3. Awesome. And then oh. Okay, yeah. So you got the sine alpha by just using this.
Some other way, but I like the way you did it. And I didn't know I could do that.
I mean, this is also a good way to solve it. You just substitute instead of cosine to alpha 1 over 3, then you use this formula 1 minus 2 sine squared alpha, and you were solving for that. And that's good that you said that since alpha is in the fourth quadrant, you picked negative sign. This is correct. And now what?
Made of some sort of little mistake on some of the other ones. Yeah, because if it's sine over cosine for the tangent, it should have been negative. Because sine is negative and cosine is positive, right?
Mm-hmm.
So I think it was just that tangent was supposed to be negative, and then that means cotangent was supposed to be negative. And then I think the other two are correct.
Okay. So you've got 4 over 3. Let me just double check. And then 2 cosine squared alpha divided by 2, which is 1 over 2, which is just 2 over 3, plus or minus. And cosine in the fourth quadrant is positive. So it should be positive square root of 2 over 3.
I think I just lost the negative sign at one point.
Well, yeah. So yes, cosine alpha is correct. Sine alpha is correct. Let's see. Tangent is 1 over cosine.
Yeah.
So you would have negative, right?
Yeah, it should have been negative.
Makes sense.
And then cotangent should have been negative too, because that's just 1 over tangent.
Yes, yes.
Secant should have been positive, and cosecant should have been negative. So I think it's just that I missed the negative signs on tangent.
Yeah, probably. Yeah, but other than that, you did a good job. Yep.
Okay.
Because there are different ways to solve it. But
Yeah. Number 5 was, I did that one like 4 times. I wrote it down that I did it like 4 times, and I kept getting the wrong answer.
Okay.
It was really close to the right answer.
Yeah.
But
let's try to solve it together. So we'll have cotangent squared alpha. Oops, squared equals to 1 minus cosine squared theta. Sine squared theta times
secant squared of theta
secant squared of theta
plus cosine squared of theta over sine squared of theta.
Okay, so we have to get to the cotangent squared theta, right? Let's try to simplify the right side. So we have, let's see, secant is 1 over cosine.
Yeah.
Okay, let's rewrite it. So we'll have 1 minus cosine squared theta times 1 over cosine squared theta, right?
Mm-hmm.
Okay, and then plus cosine squared theta. And then divided by sine squared of theta. Okay, let's simplify what's on top. So these ones go away, right?
They do?
Yes, because here's multiplication. It's like 1 over, you multiply this by this by this, then you divide them and it's just 1.
Also, it's just 1. I didn't know you could do that. I thought 1 minus cosine squared of theta was like one term, and you couldn't touch it like that. Like you couldn't get rid of part of it unless you got rid of all of it. So I turned that into sine squared of theta. I didn't know that you could do that.
Yeah, because you see, here's multiplication. It means like cosine squared theta.
Right.
It's like 2 times 1 over 2. You see?
Yeah.
Of course, you would simplify it. That's the
Yeah.
same.
Okay. So it's just cosine squared of theta over sine squared of theta.
Exactly. Which is
that's
the same
okay.
as this thing. It's actually pretty simple.
I just made it really overcomplicated. Okay.
Yeah.
All right. 6 I got right, and then 7, 8, and 9 were terrible. It was really hard.
6 you did right, and then 7. Let's see.
Yeah, 6 I got right, I guess, and then 7, 8, and 9. 7 I did, and then I did it wrong, so I erased all the work, and
Oh.
I didn't have enough time to work through it before it was 11. So
Yeah. It's better to show at least some work. Sometimes teachers give you at least some points for trying, you know?
yeah.
Okay, let's do that. So you'll have cosine fourth. Oops. Delete everything. So could you read me the equation?
It was, I think it was cosine of 4x
4x
equals 8 times the sine of x to the 4th.
Like that?
Yeah, I think I wrote it down. Just the problem. Minus 8 sine squared of x plus 1.
Okay, minus 8 sine
X squared.
Okay, and then?
Plus 1.
1. Check. Okay, so we have to get to cosine 4x. So let's think what cosine 4 of x is. Cosine 4 of x is the same. Actually, no. Let's start with the right side.
Okay.
So we have to change everything to cosine kind of thing, right? So let's see. Let's first factor out 8 sine squared of x from these two stuff. So it will be 8 sine squared x, and then we will be left with sine squared x minus 1, correct?
Yeah.
Now, if you remember Pythagorean theorem, cosine of squared x equals to 1 minus sine squared x, right?
Yeah.
But you have sine squared x minus 1. So how can we make it as 1 minus sine squared x? What would you do?
Divided or times multiplied by -1.
Well, you can multiply because we are not doing this one. You're just simplifying this right side. You just pull out minus, right? Pull out minus, factor out minus.
Oh, yeah. Okay.
And then you'll be left with negative sine squared x plus 1, which is the same as 1 minus sine squared x.
Okay. And that's cosine of square root of x.
Yes, so we will write this as sine squared x. And then here's times cosine squared of x plus 1. Now sine squared x, we can rewrite in terms of cosine as well. Also Pythagorean theorem. What will it be?
Be 1 minus cosine
squared of x. Yes, yes. So it will be 1 minus cosine squared of x times cosine of squared of x plus 1. Okay, now at this point, we could distribute. Yeah, let's distribute. It will be negative 8 minus, actually plus 8 cosine squared x. Wait, no, what am I doing?
Negative 8 plus 8 cosine x squared.
So we're kind of like distributing this and at the same time distributing this thing. Let's distribute negative 8 first. Yeah, let's do that. So it will be plus 8 cosine of squared x. This whole thing times cosine squared of x. Make sense?
Uh-huh.
Now let's distribute cosine squared of x. So it will be negative 8 cosine squared of x plus 8 sine squared of x plus 1.
Would it be
cosine? Wait. Cosine to the fourth of x.
The fourth of x, yeah.
Exactly. Okay. Okay, now let's do the left side so we see where we should head to. So cosine of 4x is the same as cosine of 3x plus x.
It is?
Yeah, because 3x plus x is 4x, right?
Right. I think I'm just fuzzy on what you can do with.
Yeah, it's like you can't really see now, but if you start like doing, you will see what will you get. You will get to. So let's if you pull out sum and difference formulas and try to open this. So what will it be? Cosine 3x plus x. What will it be?
I don't know.
Sum and difference formulas.
Sum and difference formulas. Oh, okay. It's cosine of a sum. So cosine of 3x plus or times cosine of x minus sine of 3x plus times sine of x.
Awesome. Now let's rewrite this thing as cosine of 2x plus x. Let's see, cosine of 2x plus x.
Okay.
Okay, and then sine of 3x, we'll rewrite as sine of 2x plus x. So now, what will cosine of 2x plus x equal to?
It'd be the sine of a sum, so...
No, cosine of 2x plus x.
Wouldn't you use the sine of a sum, or... Oh, sorry, the cosine of a sum again. Okay, so cosine of 2x times the cosine of x minus the sine of 2x times the sine of x. Which is, you can substitute the sine of 2x for something, right?
Mm-hmm. So let's distribute sine of 2x plus x. It will be sine of 2x, right? Times cosine of x. Plus.
It's the double angle identity, right?
No, because it's sine of 2x plus x. This thing I'm rewriting as sum and difference formulas.
Oh, right. Yeah.
Okay.
All right. And
now we can write cosine to x as 1 minus 2 cosine squared x minus 1. Let's rewrite it.
Okay.
Right? So
yeah.
I'll write it here. So it will be 2 cosine squared x minus 1. And then what? Times what?
Times, oh geez, times cosine of x.
Yes. And minus, let's use the same double angle identity. It will be 2 sine of
X cosine of x. Minus 2
times sine of x again. Okay, this whole thing was in parentheses.
Yeah.
And then it was signed by cosine of x. Then we'll say minus sine of 2x.
2 sine of x cosine of x.
Yes. Times cosine of x.
Yeah. Plus cosine, 2 cosine squared of x minus 1. Times sine of x.
And then times sine of x.
Yeah.
Okay. Let's see. So let's simplify it. Let's distribute it. So we will have 2 cosine to the third power x.
Minus cosine of x.
Minus 2 sine squared x times cosine x.
Times
cosine x. No, I timed sine and I got sine squared x.
Okay. And then times
x. Cosine x. And then this whole thing times cosine of x minus. Actually, we can remove parentheses. Let's remove it. So it will be minus 2
sine of x cosine of x squared.
No. This one, we are doing this one.
Are we?
Because cosine squared x.
Oh, yeah. Okay.
And then here was minus, and now it's plus. So it will become minus because we are opening the parentheses.
Right.
Minus. And then we will have 2
times cosine squared of x times sine of x minus the sine of x
Okay, actually, we have to keep the parentheses. Sorry.
Oh,
So
no.
here would be plus and minus, and then times sine of x.
Mm-hmm.
Okay. Let's see. Whew, that's a lot of work on the exam. Okay. So let's think. We have to change everything to cosine. So first of all, here sine squared of x is 1 minus cosine squared of x, right?
Mm-hmm.
You know what I think? Let's first distribute these cosines and sines, so we are not worrying about them. So it will be see 2 cosine of cube x minus cosine of x minus, oh wait, what am I doing? Sorry. It will be 2 cosine of
To the fourth of
x, exactly, and then it will be minus cosine squared x
minus 2 sine squared of x cosine squared of x.
Yes, and then minus, let's distribute 2 sine
squared of x times cosine squared of x plus 2 cosine squared of x times sine squared of x.
And then.
And that is that it? Minus minus sine of x.
Squared of x.
Oh, right. Right.
Okay, so these ones are good. Those are cosines. Let's change this one to 1 minus cosine squared of x. So it will be 2, 1 minus cosine squared of x times cosine squared of x. Correct? This thing. So let's rewrite it. I'll just take the different color. So there will be 2 cosine 4x minus cosine squared of x. I'm just rewriting the first 2. And now let's distribute these 2.
Minus 2 plus
cosine squared of x.
2 cosine squared of x plus cosine to the fourth of x.
Yeah, and we forgot about 2 here, right?
Oh, yeah.
Okay, done with this one. Let's see. This one, let's change this one. This one will be 1 minus sine squared of x, 1 minus cosine squared of x.
So the same thing. So it's just going to be minus what we just did.
Oh, okay. Oh, then you could have written this whole thing as 4 here, so it will be 4, and here will be 4, right?
Yeah.
Okay, done with these 2. Now.
Plus.
Oh, actually, look. Just a second. Look, we could just cross these 2 out, right? They are totally the same.
2 to the. Oh yeah. Okay.
So we are left with just this one. Okay, and we wrote it here. And now minus sine squared x, which is minus 1 plus cosine squared of x, correct?
Yeah.
Okay, these ones go away, right? 2 plus 2 is 4 cosine 4x minus 2 cosine squared of x minus 1. You see, we did everything correctly. Oh, I think we did a mistake somewhere. 8. Let's see again.
I think.
You know what? I think we should have changed everything to sine from this side, and we would have gotten something like that.
Oh, okay.
Yeah, let's see if we still could get there. So we factored out 8 sine squared x. Cosine squared of x minus 1 plus 1. So negative 1 minus sine squared x. 1 minus cosine squared of x.
I think I can see how I could have done it. It's just
you really?
Don't have to, yeah, you don't have to write it all down again.
Okay.
I think
I just think that I did a mistake or something like that. Yeah.
I just didn't know that you could say cosine of 4x is cosine of 3x plus x or 2x plus 2x or whatever.
Yeah, this is like what you usually do with when you see something to the 4th power.
Okay.
Yeah, all they ask you to. Okay.
And then number 8.
Okay, this one looks easier a little bit. Find all real numbers that satisfy. Oh, you have to solve it, right?
Mm-hmm.
Did you do the 8th one correctly?
No. I got credit for trying, but I didn't get the answer.
Okay. Hey, hopefully this one will be better.
Yeah.
Delete, and then we'll have negative 5.
Negative 5 times the cosecant of x minus root 2 square root of 2 times the parentheses, like end of parentheses and a new parentheses. 2 cosine of x plus square root of 3 equals 0.
So since here are multiplications, first of all, we can divide the whole expression by negative 5, and this will go away. Doesn't matter. Doesn't mean anything because 0 divided by negative 5 square root of 5. Yeah. Now, since here are multiplication, you could equal this expression to the 0 and this to the 0, right?
Oh, okay.
Equals to the 0, and then 2 cosine of x plus square root of 3 equals to the 0. Cosecant of
x equals square root of 2.
And then here, let's work on this one. Cosecant is 1 over sine x.
Yeah. So that'd just be
right? Because like cross multiplication.
Yeah.
And this equals to this times this, and then divide square root of 2 from both sides. Okay.
Okay. Yeah.
Now, if you look at the circle, if you have the circle, you are trying to find. This is the same as square root of 2 divided by 2, right?
Right.
So you're looking in the circle and thinking, where is sine equals to square root of 2 divided by 2? It is
45-degree angle.
It is pi over 4, right? So we'll say x equals to pi over 4. And then x equals to, let's see, 3 pi over 4?
Yeah.
And then you also have to say plus 2 pi k.
Where the sign is positive, it would be 3 pi over 4. Okay, sorry.
Right? And then you also say 2 pi k, because it's their period. Right?
Okay.
Do you know why you're saying 2 pi k?
Uh-huh.
Yeah, because if you draw the graph, right?
Yeah.
Okay.
Its period is 2 pi.
Okay. And let's solve this one then. 2 cosine of x equals to -3 square root of 3.
So it's x equals, where is cosine -3/2? That's going to be 5 pi over 6 and 7 pi over 6. Right?
Yes, exactly. And plus its period, 2 pi k.
2 pi k. Okay.
Where k is in integer.
Okay.
And that should be it.
Okay. Cool.
Those are the answers. Yeah, just remember about that you can just equal to 0 each of the parentheses, because here's multiplication. Here's plus, you wouldn't be able to do that.
Okay, that one was a lot easier.
What about the 9th one? Did you solve it?
I didn't solve that one either.
Let's do that, and you'll say what we should do.
Okay.
Okay.
So 3 times the secant of x squared times the tangent of x equals 4 times the tangent of x.
Okay.
And then I changed secant of x squared to tangent of x squared plus 1.
Okay. Okay.
I did that, and then I distributed the 3 times the tangent.
Well, do you see that we could just say that those go away? Right?
Nope, I didn't see that. Okay. That makes sense.
Sides.
So 3 times the tangent squared of x plus 1 equals 4.
Tangent squared of x equals to 4. Right?
Yeah.
Okay. And now we will have 3 tangent squared of x equals to 4 minus 3, right?
Yeah.
Okay, and then tangent squared of x equals to 1 over 3, and then tangent of x equals to 1 over square root of 3, which is the same as square root of 3 over 3. Okay?
Okay.
Now let's look up where tangent equals to square root of 3 over 3. So it means sine over cosine, meaning that y value divided by x value should give you square root of 3 divided by 3, or 1 over square root of 3.
So it's going to be... Well, that's 1 over the square root of 3. So it's going to be 1/2 divided by root 3 over 2. So that's pi over 6.
Pi over 6.
And 11 pi over 6.
11 pi over 6? It should be positive.
No, it's only positive, right? And then, they're both negative. So 7 pi over 6.
7 pi over 6, right?
Yeah. Yeah.
And plus its period pi k. Pi k.
The period of tangent is pi k, not 2 pi k?
Yeah, exactly. Cotangent and tangent, their period are pi k. For cosine, sine, secant is 2 pi.
Gotcha.
plus pi. But you know what? The thing is with this, you could write your answer as just this thing, because this thing includes 7 pi over 6 already in it. Because look, if k equals to 1, is an integer, then you would have had pi over 6 plus pi. So you would say times 6, so it will be 7 pi over 6. So you see, it includes this answer, so you don't have to write the second answer.
Okay.
You have to write only one of them.
Okay.
You should always check if you can just write one.
Okay.
Okay.
All right, that'll do it.
Awesome.
Thank you so much, Anastasia.
Yeah, you're welcome. You can always meet when you need help.
Okay. Have a good day. Thanks.
You too. Bye.
Bye.